90 days. Top pack, the packages that are mostly activated, like the ones that people like frequently activate to. So the number of this is the top pack are the packages that people mostly activate to, and this one is the number of times that clients activate those packages. And then chain is the predictor variable, whether it is 0 or 1. 0 in this case being, I'm not sure, let me verify that from the notebook. Okay, so we have those headers here in the data, and then we can also view the tail of the data. We can look at the shape. So we have over 20, we have about 2 point something million rows and then 19 columns. You can also visualize some info about the data types in each column, Then you can also look at the test data the same way. Look at the shape info, then also the submission file. So that's how it actually looks. So we have the user ID and the chain. So here it's going to be a value from 0 to 1 inclusive. 0 means, actually, let me verify this before evaluation. Okay, the values can be between 0 and 1 inclusive, where 1 indicates the customer changed and 0 indicates the customer stayed with Expresso. So here you go. So you could either stick to classifying like zeros and ones only, or you could do the probability, and any of them still works fine. And then, so we could also visualize just to see for each of the categorical columns how the levels are distributed. So we have the region column. We could see the regions in Senegal and the number of clients from those regions. Then we could have a visualization of it. So using this snippet, you could do that just by putting your column name, and you are good to go. Same way we can look at the tenor, which is a categorical variable as well. So it's being categorized as whether greater than 24 months, from 18 months to 21 months, and so on and so forth. Then we also have this part talks about whether a client is, I'm not really sure, but then it appears to be some not very useful column. So by looking at it this way, there's nothing, because a categorical value should have had like at least 2 fields, 2 levels, and we know what to, but this is just one, so it turns out to not be very useful, which we may drop. The top packages, yeah, they are a lot. So as you can see, we have them here. Probably this is not the best way to visualize it, so when you could find a better way to do that. And then we look at the actual predictor class, which is the chain, and as you can see, it's highly imbalanced. Okay, the clients who chained are way lesser than those who stayed with Expresso. So while you build your machine learning model, keep this in mind to try to balance these classes. Either you can use downsampling, upsampling. You could use other algorithms that deal with imbalanced classes like decision trees, and so on and so forth. you here is also like a summary of the integer and float fields. That's the numerical columns. Okay. If you are interested in the statistics to be able to do some feature engineering around that, this gives you an idea of what you could probably do. Then we talk about we look at missing values, because this is very important. They appear to be lots of missing values in there. One way I thought about this was to kind of, in the training data set, to drop all all rows containing missing values, because one, our data is huge. So dropping these rows wouldn't still, affect that much. But then we later realized that this may lead to losing so much information. So here we've decided to impute. Well, we'll get there, but then these are the numbers. You could see the fields that have missing values. So from here, we decided to drop the region column. You think about this when you are building your own, whether to drop or keep something, but here we are just dropping. And the top packages also, they appear to be a lot, so kind of drop. And this field, like I talked about earlier, it appears to not be very useful, so we are also dropping that. And then we also replace the missing values with the of the numerical columns with their means. Okay, so as you can see here, so we are using this line to drop the columns that are already mentioned. And then if you view it again, you see that they are gone. Then in the test data as well, so what you do in the training, you try to replicate that in the test so that they are in form. And we are running out of time, so I'll just be quick. So as we said, we are replacing all missing values with the mean of that column. So for instance, when you come here, revenue, here you see none, that's a missing value. So we replace this with the mean value of this column, adding all the values that are there divided by the total number of observations. So we replace each numerical column that has a missing value in a row with with its mean. And so when we test again, we see that there is no missing value in the training data set. In the test data as well, we do same, and when we check again, there's 000 missing value. So we are good to go. So just to have an idea, we now have a data set that has no missing values in any of the columns, and we have one or so categorical values, the tenor, that's the how long the person has been with Express. So that appears to be the only categorical value in our data set. So we go to the machine learning part. Okay, so we import some libraries to help us. So from scikit-learn, we import our train test split, cross validation score, the accuracy, confusion, all these things from scikit-learn. You could look at them. Scikit-learn standard scaler for scaling the values. This helps in our model converging earlier. We are always trying to look for the convergence point. So if your data points have values that are large, it takes a longer time to try to come to find the convergence point. So by standardizing, it just makes it easier to kind of compare between two different variables on the same scale. you know um Then random, so we are using random forest classifier because our data is imbalanced, and generally decision trees do better for imbalanced data sets. We are doing this because we are not going to manually handle that, either by increasing generating um, some test field or data for the minority class. We are not going to do that. So that's why we decided to go with the random forest classifiers to handling that. And then our label encoder will help us to encode this field to also be a numerical one. Then quickly, to build your machine learning model, you don't need the user ID in there. So we drop that, and we also don't need the chain in the test data set. I mean the training. So you have your X and your Y. So we don't the Y variable is supposed to be the chain column. That's what we are predicting. So you separate it from the X. So taking it off the training data set, I mean, so you assign that variable, the chain, to your Y, which is your Y variable, and then the rest you drop these two from the training set, and that now becomes your X. From in the test data, we don't have this column in it. We only have the user ID, so you quickly just drop only that, and you also have your X, your test data set, which is the X. Yeah, so when you look at the shape, we have that your X and your Y and the test. Okay, so quickly, as we can see, the data is very large, over 2 million um, data points. So the idea, to not frustrate some of you, so you get stuck on one model for the whole day, we decided to split this data into two, exactly two, one for test and one for trading, so 50-50. On top of that, we went ahead to split the training. So we are going to use X train and X test, Y train, Y test. So for the X train and Y train, we further split it into X train, X validation, Y train, Y validation. And the splitting is done on 70-30. So we are using 70% of the initial 50% of the whole data for our training, and we are using 30% of that for testing and for validation. This is very important when you want to view validate on training, so you can use that. But for in this notebook, we didn't use this validation test, but this has helped us to have a sizable data set. So when you are splitting, you could look at better ways, probably if your system can handle like 80% of the data of that whole 2 point something million, you could use that. But here we decided to do this so it will be faster for us. And so we have these columns. What we will be doing is that we want to standardize them, to put them on the standard scale, so as we already imported the standard scalar, we initialize it here, and all the columns, all the numerical columns, we fit them, we fit transform to put them in this on this standard scale. This standard scalar is the z-score in statistics, so you could look at it, what it does and stuff. You could also use other scalars like the min max scalar and others. Then you do same to the test, but realize that we have already fit it, so we don't fit on the test data again. You fit and you transform on the training set, and you transform only on the test set. and then you are good to go. But yet we still have this column that is a categorical value. We do same for the test. That this test data is the one that we use to make submission to Zindi. So we are not touching it, but then we try to make sure it's also in the same order. Yeah, so and then we do for the validation set also in case you would use it. Then we come to the encoding. So we, as we already said, this field is still categorical. So we encode it to become a numerical. So it will assign values from one upwards. So we have, depending on the number of classes that you have here, you assign numerical values to that. And as this is not very huge, we decided to leave it like that, not scaling with any. But then you can also think about it, whether to use a standard scaler to also scale it, which whether it may help or not. Then we come to our random forest classifier model. So we initialize it with these parameters, with max depth 7, number of jobs -1. Yeah, so you could modify these when you are using, just to see if it works better for you. And then we fit it on the X train, Y train, and see that it didn't use much time, probably due to our machine capability or something, but it finished in like 1 minute and something, you know. And then we predict it on the X test, which also took not up to a minute. Checking the accuracy, again, note this, okay? So you don't have to base yourself on the accuracy, but rather the recall or the precision and probably the confusion matrix. So it has a recall of 0.5. You can read about recall, what it means, F1 score as well. Precision, we didn't check precision, but you can look at the precision. Then confusion matrix, okay. This just shows how many um, how many um, chain classes it was able to um, predict, and how many correct um, customers that state that is able to predict. And this other side looks at the deviations, you know, the wrong classifications and stuff. You read about confusion matrix and know what it does. And then we are trying to now make our submission file. So we already imported the sample submission, and we view it here and see what shape it is in. And so now we make, also we look at the test data, the one we'll be using to make the submission. And then we now use, because we have our model trained, which is this model, random classifier model, rand model. So we use it to now fit on the test data here. We now predict it on the test data. And when we visualize, we would have like these values 0, 0, 1, 1, 0. So these are supposed to be zeros and ones. We are using just the classifier. You can use the probabilities, which will be between 0 and 1 inclusive. So we replace this column, the values here, with the predicted values we got from predicting our model on the test set. So just saying submission of chain is equals to this one, these values here, works better. It's just facing there, and we are good to go. So we have our submission data frame, and we write it to CSV as starter code submission.csv. And when you run this code, it will create a file in your current folder with this name. So you go to the Zindi platform and click on submit, upload this file, and you are good to go. So it will um, give you a score based on how your model performs. we are already running out of time. So just to give you some recommendations, you can do more feature engineering. You can handle the imbalanced nature of the data of the predictor class. Use other algorithms that can make it better, just to see how you are performing on the leaderboard. Tune the hyperparameters that are already in the above model. You can handle the missing values in some other ways that you find appropriate, better than how we've handled it here. And any other thing you feel that can improve the performance of your model, feel free, but still follow the rules and do not use a non-open source packages or anything that infringes upon the rights of Espresso clients and all the sponsors, and you know. So good luck on all participants.
To join our YouTube channel, kindly hit on the subscribe button.
aighana, like, subscribe, and share.